Okay, as a reminder from Math 1, we learned how to solve systems with 3 different methods. So what do I mean by solve systems? I mean, we've got 2 linear equations, and they sometimes touch at one place, and this place was called the solution or the point of intersection. So we could graph 2 lines and see where they touch, and we'd say, oh, there's the solution, there's the point of intersection. But that would be using the method of graphing. What if we didn't want to graph them? We learned 2 other methods. The first method we learned was called substitution, which I'll demonstrate here in 4A. And then the other method, the third method, was called elimination. And these 2 other ones, B and C, I'll demonstrate the elimination method. So how do I know something's set up nicely for substitution? If I'm given 2 linear equations, just like part A here, and one is already isolated with its variable of y equals, I know that I could easily plug in this entire back part, y equals negative 2x, in for y. So what does substitution mean? It means I'm going to substitute that entire expression in for the variable. I'm going to plug it into the other equation. Here we go. So I get the equation ready. 2x plus 3 blank equals 9. Why am I leaving that big blank for the y? Because all of this can get plugged in for the y. So here I go. Negative 2x minus 1. So now I'm going to start by distributing. So 3 times negative 2x, do you see how that would give us negative 6x? 3 times negative 1 would give us negative 3, and then leave that equals 9 and leave this 2x alone. All I did in that first step was distribute that 3 that was out front. Next, we're going to combine like terms. We've got 2x's and negative 6x's. Do you see that that gives us negative 4x's? We subtract, keep the sign of the larger. Now we're going to add 3 to both sides and divide by negative 4. I just got a solution for just the x value so far. And so negative 3, comma, I have to figure out what the y value is that goes along with this. I need the other half of my answer for that point of intersection. So I'm going to take this x equals negative 3 and plug it back into either equation. Well, I want to use this smaller, easier equation. I'm going to use the top one. So if y equals negative 2x minus 1, I'm now going to get it ready with a big open space for the x, because I just found out right here that x is equal to negative 3. So now I can go plug in negative 3 for x right here. Okay, plugging in that negative 3, we now continue solving. We get negative 2 times negative 3 is 6. 6 minus 1 gives us 5. So now I have my 2-part answer. Negative 3 for x came from us solving this first part. Oops, just kidding. Let's get that highlighter out right here. And then when we solved and we got that y was equal to 5, that's the other part of my answer. Notice how I write that solution as a full coordinate pair. It's a point of intersection, and you need to give the answer in the x, comma, y format. This method is called solving systems by substitution. If watching this, you were sort of shaky on it, like, ooh, I don't remember that. Don't worry, we're going to be practicing it one more day this week. But also, you may need to go watch a video or 2 to get you caught up. Maybe take some notes on that. So in class, I'm showing a reference of what you could watch for other videos. So that's the substitution method. Now let's go look at elimination method. Looking at part B, what makes this nicely set up for elimination? Okay, now don't write this down, just watch for a second. What would make something nicely set up for elimination? First hint would be if it was set up in this format. This is called standard form. If it's set up with a number x plus some number y is equal to a number, and it's set up in this standard form, and both equations are set up in this way, check it out, x's plus y's equals a number. If it's set up like that, we know it's set up for elimination. The second part is we need opposites in order to eliminate one variable. What's an opposite? If I had my first equation of 2x plus 3y equals 6, and I had my second equation as negative 2x plus 4y equals 8, do you see how the 2x on top and the negative 2x on the bottom could easily be eliminated? Bye-bye, 2 minus 2 equals 0. And then we could add up the rest of this in order to solve for one of the variables. This is how, if I have those opposites, I know that I should probably use the elimination method. Now, like I said, you didn't need to write this. This was just a quick recap on elimination. Let's go take a peek at our part B now and see if we have those opposites or how we can get those opposites. So first, looking at the x's, do you see how here I have a 4x and here I have a 2x? Shoot, there's no opposites there. Let's look at the y's. Here I have 3y, here I have negative 9y. Shoot, there's no opposites. Could I multiply one row easily in order to make opposites? Take a minute to look at it. Now, hopefully you're thinking, well, I've got a 4x up here. I wish I had a negative 4x down here. How could I get that negative 4x? What if I multiplied this entire row by a negative 2? So check this out. Negative 2 times 2x, there's that negative 4x I want. Negative 2 times negative 9y, and negative 2 times 35. I just made an entire equivalent row that is negative 2 times bigger. Now I'm going to go grab this original row from the top, 4x plus 3y equals 7. All I did here was change one row. And now I have opposites. Is there something I can cross out now? You bet there is. 4x's and negative 4x's cross out. 18 plus 3y's, there's my 21y. Negative 70 plus 7. Do that on a calculator if you need to. And final step, dividing by 21. All that work, and I just got 1/2 of my answer, the y equals negative 3. Remember, I need a two-part answer. I need an x comma y. So let's go choose either of the two equations and plug back in. I'm going to choose the top one, 4x plus 3y equals 7. And I'm going to get ready to plug in the value I just got for y. Okay, so what did I just get for y? Check this out. I can see right here that I got y equals 3. So I can go plug that in. Negative 3. I think I said negative. And now we solve. So plugging in, substituting in that y equals negative 3. I plugged that in for y. 3 times negative 3 is negative 9. So add 9 to both sides. We get 4x equals 16. We get x equals 4. Now I've got my two-part answer, 4 comma negative 3. How'd you do? Pause the video at this point, see if you can go figure out what would we need to multiply by in order to make opposites on the next one using elimination. Okay, let's check it out. Let's see what you thought. First, looking at the x's. I've got a 5x and a 3x. Shoot, there's no opposites. Next, looking at the y's, I've got a negative 3y and negative 4y. Shoot, there's no opposites. So I'm going to have to make opposites out of these. Can I make a 3 into a 5? No. Can I make a 3 into a 4 on the next one? No. So I'm going to actually have to multiply, and I have to change both rows in this example. So how would I change it? If you wanted to go for the x's, do you see that 3 times 5 is 15? So I would multiply the top row by 3, the bottom row by -5, and it would give us 15 and -15x. That's your first option. Do you want to do that and go for the x's? Option 2 would be to go for the y's. Notice I have a 3 and a 4. What if I multiply the top by the 4 and the bottom by -3? Do you see that that would make 12 and 12? One would be negative, one would be positive. That would be if you wanted to go for the y's. Both options work. So you pick which way you want to do. I'm going to go forward with going for the x's. So I'm going to multiply the top row by 3, the bottom row by -5. Let's make these 2 new rows. Distributing that 3 to all the parts, 3 times 5, 3 times -3, 3 times 11. Do you see how I got that top row? Let's go do the bottom. Double check me on that. 22 times 5, is that what we get? Now we've got our opposites. Now something crosses out. -9 plus 20 gives me 11y. 33 minus 110 is -77. Divide by 11. I get that y equals -7. All this work, and that's half my answer. I now need to plug into any of the equations in order to get the x value. So which one do I want to use? It's up to you. I'm going to choose the top one. You pick whichever one you're more comfortable with. Okay, so 5x minus 3y is 11. I'm going to leave a big open space at the y because I'm able to plug in the -7 that I just got from right here. See how we got y equals -7? So plug in -7 for y. -3 times -7 is +21. I did something wrong. Hang on a second. No, I didn't. Okay, 5x equals -10. Divide by 5, divide by 5. We get that x is equal to -2. And so our final answer, our point of intersection, is -2, -7. How'd you do?